We're going to skip topic 5. There's some procedural things and combining like terms and multiplying conjugates and things. Hopefully we can pick up on it. And here there's just two major items here: principles of power and radical equations. So let's see if we can fit these in. So number one is if you have an equation in which there is a radical with its radicand, that's called a radical equation. And the principle of power is that if you square this side and you square that side, they're still equal. And that's called the principle of power. And we'll use it right here in number 3. Now, how do you get rid of a radical? Well, you look at the index number. Again, we don't write the 2, but we're going to raise then this radical to the second power, and we do the same thing to the other side. So when we do that, we take away the radical sign, put this 2 under this 2, and it just becomes the radicand. And we're going to add 7 to both sides. Divide both sides by 3, and we get 32 thirds. And if you put 32 thirds in there and subtract 7, you get square root of 25 is 5 equals 5. It checks out. So a couple of things are going on now. The rule is isolate the radical. So this will become the square root of 6x. Now I'm going to transpose that. That will give it a 10 on the other side. And then we square both sides. And this just gives us a 6x equals 100. And we get x equals 100 divided by 6, which will reduce to 50 over 3. And in this one, again, we're going to transpose this. So we get then the square root of n minus 8 equals 3. Square both sides. N minus 8 equals 9. Transpose that. That gives us a 17. So we get n equals 17. Same thing here. Square root of z plus 2. Subtract 6, or transpose. We get 4. Square both sides. We get z plus 2 equals 16. C equals 14. So again, the equations aren't difficult so far. It's just knowing the procedure to isolate the radical and then use the principle of powers. So, as we continue, notice they've changed our index number. So what power will we raise both sides to? 3. So this then becomes t plus 3 equals 64. T equals 61. And here we're going to raise it to what? Yep, 4. And we get y minus 9 equals 16. Y equals 25. Now, here, I was reflecting on the easiest method, and I think it's just going to be to square both sides. So here we get then 7a, or I should say 49a. Let's erase that. Yes, remember the 7 is not under the radical, so that's 7 squared will be 49a, and then that equals a squared. So now we have a quadratic, and we solve that by transposing that, and we get a squared minus 49a equals 0. That's standard form. We factor out the a, and we get a minus 49 equal each of these to 0, so a will equal 0, or a equals a positive 49. And both of those answers check. Okay, I've done a little bit to this. I've converted this to this. So I will now square. Well, here's a case where before we square something, I'm going to divide both sides by 6. So I now get the square root of x here equals 2. So I transpose that to get the 12. Now I square it. And I get x equals 4. So a little different technique there. And here I'm going to raise to the third power, and I get here x equals a negative 10,000. Now I have z to the 1/3 power, which is the third root of z. I'm going to add 1 to both sides. I get 4. I'm going to cube both sides, so I get z equals 64. Now every once in a while they throw in a challenge, and this, remember, will be the square root of something is equal to a negative. Can't have that. So for this one, there is no solution. Tricky. Remember, the square root of something cannot equal a negative. So in number 14, I'm going to transpose that to the other side. Now when I do that, I end up with a positive 2 there. So even though it's an even root, that's okay. And then for 15, I'm going to convert that to the third root of that, which equals 3. And by the way, what do I do up here to solve that? I have to raise it to that index number of 4, and this side to 4, and this side to 3, and this side to 3. Remember the principle of powers rule. And then here I'm going to subtract 5 from both sides, and then raise this to the third power and this to the third power. I hesitate a little bit to work these out, but I said, well, why not? So raising this to the fourth power, it just becomes the radicand. This becomes 16. I subtract 3, get 14. I divide by 2, I get 7. This becomes the radicand. This becomes 27. I subtract 4. T is 23. Raise this to the third power, Raise that to the third power, get 27. Add 1 to both sides, divide by 4. Y is 7. Something new coming up. This one is actually pretty easy because we're just going to use the principle of power rule to square both sides. It just gives us the radicants. We're going to subtract 5z, get z. Subtract 1, get 2, and there's our answer. Now these we have to work a little bit. Now number 18 is a little more challenging, so I've worked it out to save a little time. Here, this is going to be put into its radical form, and we'll raise this side to the 4th power. And this in its radical form raised to the 4th power. So 2 to the 4th power is 16, and just the radicand, and this becomes 8. But then to help simplify things, and you could do it this way or not, I'm dividing both sides by 16. So this side becomes 1/2. So here's what I have in red, which looks pretty simple. There's a couple of ways to do it. I chose to multiply each term by a -2 so that my y became positive. So this is a -6, a positive 2y, and this is a -1. I transposed my 6 over to this side as a positive 6. That gave me my 5, and I divided both sides now by 2, and there's my answer. Again, there's other ways. I think the other way would be more complicated. This is complicated as well, but I think perhaps the simplest. But other ways are okay to do it. Now, we'll do this one in parts so you can follow it very accurately. This is going to use some of the techniques that were done in the section we skipped, so I'll take a little more time going over it. So we have to take the 7, transpose it. On this side it becomes a -7. So we have this. Now what we do, use the principle of powers that we're going to square both sides to get rid of the radical. So this then becomes 4 times x plus 1 equals, we have to square that, so that's x squared. Multiply these and double it, minus 14x plus 49. This is a technique from an older chapter. So this becomes 4x plus 4 that I'm now going to integrate on this side. So this is x squared. On this side it becomes a minus 4. So that makes this a minus 18x. And this is a plus 4. Becomes a minus 4 on this side. So that then becomes plus 45. And then all of this now equals 0. Okay, I have to factor that. Now you've done a lot of work so far. So we take each of these factors, equate it to 0. So here x will be a positive 3, or x will be a positive 15. Now an interesting thing happens. When you put the 3 in there, it does not work. We have developed what is called an extraneous root by using the principle of powers system. So that's why we have to check our answers. This one doesn't work. This is the one that works. So in Math Lab, you would only put this. Now on a paper test, I would actually give you credit if you put 2. And you might say, why would you do that, Mr. Paulin, or the teacher here who's giving the lesson? Well, because you did all of this, and you maybe just didn't check that last part. So if you had 5 points, I may take off a half. But I would give you full credit. But again, in MATLAB, you have to put this one. So if you get something like this when you're doing your practice, check to see which one works in the original equation. We'll do this one in steps 2. So, as we square this side, we just get the radicand. As we square this, we use the method of squaring a binomial, which they reviewed in the previous section that we skipped. So we'll do it now. Square that first term. That gives us a 1. Multiply these two terms together, and it gives you a 1 this. Now double it, times it by 2. So 1 times 2 is 2, that. So that's our middle term. And then we square this term here, which just becomes the radicand. Now we have to group like terms and isolate our radical. As we go over this step, I'll check my work here. So we have here a 4x on this side and a 5x. So I'm going to subtract 4x, I get an x. Now here I have a 1 and a negative 2. I'm sorry, negative 3, which will give me a negative 2 that I'm going to add then, or transpose as a positive 2 to this side. There's where I get my 3. Okay, I think I'm in good shape. Now what are we going to do? Well, we're going to square this side and square that side. So this becomes x squared plus 6x plus 9. Square that, multiply this, double it, square that. This then gives me, this squared is 4 times 4x minus 3. Okay, so we are at this step where I then transpose, or not transpose, but use the distributive principle. This gives me 16x minus 12. Now I'm going to transpose this to this side. Becomes a negative 16x, and that is this. This becomes a positive 12, gives me that. So now I have a quadratic in standard form. I need to factor it. Well, x, and then 7 and 3, and they're both going to be minus. So here, x will equal 3, x will equal 7. Now, will one of these or both of them work? And the answer is both work. And look at all the work you did just to solve one problem. So if you get these right, you've really come a long way, and congratulations. For these, I'm not going to take it all the way because it would make the tape very long, but I want to go over the strategy of it. So here we have a 7. Here we have an 8. So the rule is we want to isolate one of the radicals. So I would suggest you subtract 7 for both sides, and then you get the square root of 10 minus z all by itself. And this is a 1 plus the square root of 1 minus c. So what do we do here? Well, we're going to square both sides. And we've done one like this already. So, you have to expand that binomial. Now here, you have two radicals. So the rule is isolate one. So I'm going to take this one, bring it to the other side. So I then, on this side, I'll get a positive square root of 4y minus 3. So on this side now it's gone. And now we'll square that. in a similar way, and we'll square that. So again, we've done that. You know the technique, it just takes time. And for number 23, they have these where we say that that equals 4. So basically, it's only going to be an equation of this on one side and the 4 on the other to start off with. Then we're going to bring this one term perhaps to the other side as the negative square root of x. Square this side. This is gone now, and that's what we do. And the same thing here. This equals a negative 2. So again, what I would do is I like to have positive numbers. I'd bring the 2 over here. And then I'd bring this over to the other side, where it becomes positive. And once again, we're going to square both sides. And these are just tedious because they involve squaring a binomial and then combining like terms, isolate the new radical, square that, square the other side. And again, once you get your answers, you need to check to see if in fact you are getting extraneous roots. And I think that's all we're going to do. Now we have section 7 that we're skipping, and we'll go on to section 8, which is complex numbers.